were discussing about AC, right? And what did we understood? Right. So we from generator we had this kind of voltage, right? And then we calculated all these things from right. Then we calculated this EMF, right? The voltage that we got from the generator. So this has these had four important values. One was this peak voltage, the other was this average EMF, then average EMF in half cycle, and then RMS value, right? And then we also talked about that if we have voltages, let's say you have one voltage which is one is let's say V2 cos omega t, right? So then your RMS value, so then your RMS value that would be square of this V1 RMS square plus V2 RMS square. And what is V1 RMS? V1 RMS is V1 by, right? V2 RMS is V2 by. Similarly, same case with the current as well. So if you have a current which is I1 sine omega t plus I2 another function of cos omega t. So the current RMS value would be just like this one. So whenever the voltage is dividing in parts, then you take the RMS values because these have different phases, right? They will not add up like this. They will not add up like this, right? They will add up like this. And same case with current. So if you have two currents which are in different phases, then one. So RMS would be I1 RMS square plus I2 RMS square. And you can also write this thing as IRMS square. That would be equal to how much? I1 square by 2 plus I2 square by 2. And how do we get this value? Because I1 RMS, that would be I1 by 2. Similarly, I2 RMS, that would be I2 by 2. So if you calculate I1 RMS square, so that would be I1 square by 2. Similarly, this would be I2 RMS square, that would be I2 square by 2. So if you put back this value in here, so I RMS square is I1 square by 2, I2 RMS square is I2 square by 2. So then this whole I RMS overall square, that would be I1 square plus I2 square by 2. So they will not add up they will not add up like the algebraic sum, right? This would not be true because these are not at similar phases, right? So if you have two circuits, right, and both have, let's say, I current is flowing, then I1 goes here, I2 goes here. So you can write, in this case, you can write I1 plus I2 from junction 2. But when you have this inductor and you have this resistor, then you cannot add up like this. Then you have to add up like. Is it clear to you? Is it clear to you, Tal? Yes, Tarif, is it clear to you?
Yes, sir.
Okay, then please note down this part, and on the basis of this, we will so note down this part, right? And on the basis of this, we'll do some questions. Whenever you have noted it down, that. And now what I will do is that I will directly write the results that you have got already in your CBSE class, right? So I will not talk about phasor diagram and all. I will directly write the result that we get from phasor diagram, using the phasor diagram. Whenever you have noted it down, please. Yes, noted. Tarif. Yes, Tarif, noted. Hello, Tarif, can you hear me?
Yes, sir, I'm noting it down.
Oh, yes. Because I want to complete up to this decaying current and decaying charge. We have at least complete LR circuit and RC circuit. Two circuits we have. One money. Yeah, whenever you have noted it down, Tariq.
The I square RMS equal to I1 square plus I2 square by 2.
Yes. Because what I have told you that IRMS whole square that would be I1 RMS square plus I2 RMS square. And we know that what is I1 RMS? If you calculate the RMS value of this thing, right? So this would be I1 RMS would be I1 by root, right? I RMS square would be this thing, I2 RMS would be this thing. We put back this value in here, so you'll get is it clear to you? Yeah, whenever you have noted it down, and if you have any doubt, please tell me.
Yes, sir, done.
Done. Okay, so then yeah, let us do few problems based on. So the problems would be the direct problems, and what are those questions? Yeah, so this one, but we'll come to this question later. First, let us check. Yeah, the direct one. So you see, you have this combination of current, right? And you already know that the overall measurement, so we measure the RMS value, right? Diameter or whatever galvanometer that measures the RMS value. So what would be the measurement that we would be getting in diameter? That would be IRMS, right? And this would be how much? So that would be how much? What would be the correct answer? Which one would be correct? Reading would be IRMS, right?
Yes, C.
D. Okay.
No, C.
Remember, yes,
Option C.
option C. Or what is the result that we, this would be reading, right? This would be the
Yes.
diameters reading. And what do we know that IRMS square, that would be I1 square plus I2 square by 2, right? This thing, correct? Right. So if we calculate IRMS,
Then it will be root 2, right?
so we are calculating square, right? Yes. Did you understand this derivation? Did you understand
Yes,
this
sir.
part?
So then
So
if
this
you
is,
take the root, then it will be I1 plus
yeah,
I2, the whole, then root 2 by root 2. Right?
yeah. So then this would
Yes, sir.
be
Option
by
C.
C
Third option.
again.
No, third option. Sorry.
Oh, again, look
I
carefully.
think, sir, am I not audible?
Yeah. You are audible. Yes.
Uh,
Look carefully. Which is this option?
B.
B, right? How this whole square? This is not the whole square. This is individual square,
Oh,
right?
okay.
This is a square plus b square, and we cannot take a square plus b square as a plus b, right? Because this is whole square, right? If it would have been plus 2ab, then it would have been root of a plus b square, then we can take. But this is the individual square, right? Put 3 square plus 4 square, we cannot write 7. Can we write that?
No, sir.
Right? This is 3 square plus 4 square is 9 plus 16, which is 5. Yeah, exactly. So the option B, is it clear? Please note it down, and then we will do another question which is similar to this. Clearly note it down. And always remember that whatever the supply is given, so in the household, it is given that the supply is 220 volt. So this 220 volt is what value? This is RMS value, right? All the calculation will be done in RMS values. Whenever you have noted it down,
So this RMS value is only in JEE, right? It's a JEE formula, not CBSE.
yeah, this is J, right?
Yes.
In because in CAPs you will not have those combination of currents. This part you will not have.
Yes, sir. Done.
Okay, so let us do another question. And question. The other question is this is the question. Okay, again in this question, we have two combinations of current. So I is, this is root 42 sine whatever pi by dt, right? And plus 10, right? So what is the peak currents in both the cases? What are the peak currents? If we compare it with this thing, right? So what are the peak currents? We can write this thing as of 42 sine pi by t is omega, right? Plus this is 10 cos omega, which is 0 t, right? So this we can write. So what are the two peaks that we have? One peak, I1 is root 42, right? Clear?
Yes, clear.
And what is the other peak? What is the other peak value? These are the peak values, right? What is the other peak value? If I write current as I naught sine omega t. So this is the peak value, right? If I write voltage as E naught sine omega t. This is the amplitude, which is the peak value, right? That we have learned from here. This is the peak value, right? And that is determined by this graph. So this is the peak value. So these are the peak values, right? 42, and the other one is 10, right? Is it clear?
Yes.
Then we have to find out what is the RMS value. So RMS value would be how much? That would be I1 square by 2 plus I2 square by 2, right? Or I can write this one as directly uh, by 2, right? And this is the RMS value. Is it clear?
Yes.
So this would be how much? This would be 40, I1 is 42 square plus this is how much? 10
100.
square, and divided by, this would be 42 plus this is 100 divided by 100. So this is how much? 140 divided by 2. So this is 71, right? So this would be how much? RMS values would be, this is how much? Oh, Chavez is joining. RMS value 71 is how much? How much is this 1270? Yes, 71 is how much? Calculate this. Right. So this is 8.43, right? So this would be 8.4. That would be the RMS value. Is it clear? Is it clear? Yeah, is this clear to you, Tarif? Yes?
Yes, clear.
Yeah, so first we calculated the peak currents, right? In this one, the peak current is 42. In this one, the peak current is 10. So as we know from this thing, right, that this RMS value is root over this thing, right? So root of 42 square, so that would be 42 and then 10 square, so that would be 142 divided by 2, so this is 71, so this would be root of 71, which is 8 point. So this would be the RMS. Please note it down, and if you have any doubts, please, yes, Chavez. Yeah, hello, Chavez. Can you hear me? Assalamu alaikum, Chavez. Yes, Chavez, can you hear me? Yeah, so we are just discussing about if we have combination of currents, right? If we have combination of currents like this one, then what would be the RMS values? That is what we are discussing, right? And we know that RMS value is this one, right? This is how we get the RMS value. These are the things that we have discussed. So please note it down, this question, and then we will move on to the next topic. Right. Please note it down.
So I1 will be sin t, sin omega t value, and and I2 will be cos omega t value.
Yeah, so this is 10 cos of 0, right? We can write this thing as cos of 0. So this would be the amplitude of these two currents, right? In this form, this would be the amplitude, right? So if we write it in this form, so this would be the amplitude. Is it clear? So
Yes,
I1 is this, and I2 is this. So then we can write the RMS value. Is it? Yeah. Please note it down, and whenever you guys have noted it down, please. Yes, noted, guys. Done.
yes, sir.
Okay, so then now let us, because these things you have already done in your CPSC parts. So I will just recap those things quickly. I will not derive. I will just write it down, and you guys, yeah. We have already learned that if we have the, let's say, this input voltage, which is V naught sine omega t, this we get from the generator. And this is R. So then this will be, so this I would be, right, that would be simply I naught sine omega t, and phase would be 0, right? And the resistance is R, right? So these things we know already. And if we have this inductive circuit, right? So for the case of inductive circuit, what happens? This is V naught sine omega t. So do you guys remember? First, we have this reactance XL, and this is how much? This is omega L, and this is called inductive reactance. voltage by pi by 2. Yeah, so which one is leading, which one is lagging? Yes, which one is leading, which one is lagging? So V is V naught sine omega t, right? What is I? That is I naught and sine and omega t plus pi by 2 or minus pi by 2. What is happening? Yes, guys, is it plus pi by 2 or minus pi by 2? If you guys remember this. Whenever you guys have some difficulty remembering, so always go to this diagram, right? Always go to this diagram. So you have this R circuit, right? You have this input voltage, and this R circuit is ahead of, so current is C. Current is with the same phase as I. This is your VL, right? So you can see that voltage is leading. So voltage is leading, which means that current is lagging. So current is lagging by 5 by 2, right? Yes, so minus 5 by 2. So this would be the current in the case of this inductor, and this is the inductive reactance. So we have a phase difference of pi by 2, right? And similarly, we have this capacitive circuit. So in the capacitive circuit, what do we have? We have this V naught sine omega t, right? And this is C. So for this case, we have this capacitive reactance, which is 1 over omega c, right? And current that we get is sine omega t plus pi by 2, right? So this current is leading of this is our capacitance, and this current is leading ahead by 90 degrees. This is what we have done, right? And similarly, phase difference is how much? Again, pi by 2. So these two are called wattless current. Why wattless current? Because the power factor is defined as cos phi, and this is how much? Cos pi by 2. This is 0 for yeah. So this is 0 for inductor and capacitive circuit. And now comes the and we also have this power dissipated. Power dissipated is how much? I'm directly writing these things because these things you guys have already learned in your this is the power dissipated. Power is VRMS, IRMS, and cross line. Okay, and then we will get to this diagram. So this diagram is LCR circuit. In LCR circuit, what do we have? LCR circuit, we have this inductor, we have this capacitor, and we have this resistor. And the supply that we are providing is this one, V naught sine omega t. This is LCR. So I will directly write the result. You guys have to remember this diagram. So always remember this diagram that we have this input voltage. Input voltage is V naught. This is omega t. And you have this current, right? This is VR and the current is I. And current is how much? The current that you are getting in this circuit is I naught sine omega t plus phi n. Right. So this phi is dependent upon what kind of circuits you have. If it is capacitive circuit, so there would be some lagging. If it is the inductive circuit, so then this would be right. So you guys, yeah. So you guys have remember that this is VC and this is VL, and the if we draw this, if we take this VL in this side, right? So this becomes the diagram becomes VC minus VL, and then this diagram, right? Okay, so this diagram is so this diagram is VR, right? And then the equivalent voltage that you get by using the Pythagoras or the parallelogram law. So that is this thing, right? So this is omega t. This angle is phi, right? This is V naught. This is how much? This is VC minus VL. So if we use the parallelogram law, right? These angles are 90 degree. So this is your hypotenuse, right? This is your hypotenuse. And if we write this diagram, so this diagram is very important. This is phi, hypotenuse is V naught, and the base is VR, and this is VC minus VL. So if we write tan phi, that would give us the phase angle, right? And if we write cos phi, so that would give us the power factor, and that would be how much? That would be base by hypotenuse, right? So now we can write this diagram in terms of our and also we can write this equivalent voltage that would be equal to Vc minus VL square plus VR square. And if we write it in RMS, so VRMS would be VCRMS minus VLRMS whole square plus VRRMS whole square. So this we can also write it down. And then we can also write this diagram in terms of impedance, right? If we write V naught as I naught Z, if we write VR as I naught R, if we write VC as I naught XC, if we write VL as I naught XL, so then we will get this diagram. Then we'll get this Z. This is phi. This is R. This is XC minus XL. Then we can write this tan phi in terms of XC minus XL by R. We can write cos phi as R by Z. And we can write impedance as of R square plus XC minus XL whole square. So these are the things that we can write it down. And then we have certain scenarios. We have resonance condition. And what is the resonance condition? At resonance, your XC becomes XL. So Z becomes how much? R square plus XL minus XL whole square. So Z becomes R. And this frequency that you will get, which is called the resonating frequency, that would be 1 over L. Because if we write this thing, so XC is 1 by omega naught C, XL is omega naught L. So if we solve this thing, so we'll get omega naught square as 1 by LC. So omega naught would be 1 over 12. So this is the resonant condition. And then we have this quality factor as well. The quality factor is how much? That is omega naught L by R. And we can also write the quality factor as omega naught by 2 delta omega. So this is the spread of this thing, right? So at this point we have this is the omega naught, and this is omega naught plus delta omega. This is omega naught minus delta omega. So this is spread is what we call the quality factor, right? So if this is sharp, then this value would be higher, and yeah, according to that we can calculate. So this is the other thing, right? And also we get this delta omega as R by 2. So all these values we have to remember. And yeah, this is all about all these kinds of circuits, right? So please note it down, and then we'll do some questions on. Please note it down, guys. Then whenever you guys want me to scroll down, please. Yeah, whenever you guys want me to scroll down, please tell. Yeah, whenever you guys want me to scroll, please tell. Yes, done.
Can you explain the wattless current?
Wordless current, yeah. So in wordless current, what happens is that when you calculate the power, right? So when you calculate what means, what is associated with power, right? So in power consumed or power dissipated in L and C circuit individually, right? So how much is that? That would be VRMS, IRMS, and cos of phi. And we know that power factor for this L and C circuit, that is how much? That is zero. Power would be zero. Power is zero, which means that that is wattless, right? Total average power consumed is zero. That is why it is called wattless, powerless current. Is it clear to you? Yes, is it clear? Yeah, quickly note it out, guys, and whenever you guys want me to scroll down, please. Yes, guys, done. Yes, guys, noted.
If I noted.
Then please turn spots, right? Phi, right? This thing is phi. Total is omega t plus phi. Yeah, noted this point. Yes, quickly note it down and then get lots of questions. Yes, guys, noted. Yes, everyone, noted. Tell me whenever you guys have. Okay, good. Yeah, please have it down, please. Whenever you guys want me to scroll down, please. Yes, guys, done. Yes, guys, where are you guys? Muted? Yeah, whenever you guys have completed, please tell. Because we have to do some question answer, right? Done, everyone. Noted.
Oh, 1 minute.
Yeah, please tell me whenever you guys have. Yeah, please tell me whenever you guys have. Yes, what about Tariq?
Yes, sir.
Okay, then yeah, so these type of question has been asked many a times, right? And you will be given some circuits, and then you have to figure out which part is short circuited and which part is open circuit. So what is a short circuit? Short circuit is a circuit which provides zero resistance. So right, so let's say you have this inductor, right? And this has been short circuited. So then this would be just like right. So this is short circuited. And what is the open circuit? So open circuit is, let's say you have this inductor and it becomes, this is short circuited, and this becomes the open circuit. So in open circuit, this would be the scenario. So this is the open circuit. So in open circuit, no current flows, right? So these things we have to be very careful. And from the case of, let's say, inductor and capacitor, let us understand. So we know that what is XC, right? So this XC is the capacitive reactance of the capacitive circuit, right? And this is 1 by omega C, right? So if this omega is very large, right? Let's say infinity, then this Xc would be how much? 1 by infinity, which is 0. So then this would be short circuited. Is it clear? And if this omega, if this omega is, if this omega is 0, right? Let's say you connect it with DC supply, connecting with DC supply. Then what will happen? Then this would be uh, XC would be how much? 1 by omega C. This omega is 0, right? Omega is 0. So the 1 by 0 is undefined. So then this would be open circuit. Yeah. 1 by this would be infinity, so open circuit. Similarly, you have this XL, that is omega L. So for omega equal to infinity, right? This XL is infinity, so this is open circuit. And if this omega is 0, then your XL is 0, which means that it is providing zero resistance, right? So this will be a short circuit. So quickly note down this thing and then we'll start with questions. Quickly note down these questions. Yeah, quickly note it down, and whenever you guys have noted, please.
What is SC and OC?
Oh yeah, SC is a short circuit, OC is open circuit. Let's see.
Okay.
Yeah, whenever you guys have noted it down. Yeah, please guys tell me whenever you guys
Sir, can you hear me?
Yeah, can I what? Yes? Yes, Chavez, what did you say?
Can you hear me?
Yeah, you are saying that can you leave?
No, like, sir, can you hear me?
Yeah, I can hear you. Yes, I can. Yeah.
Sir, like, what is the difference between short circuit and open circuit? Like, in open circuit, current doesn't flow.
Yeah, so in open circuit, the current doesn't flow. And what do I mean by, so this XC is 0. What do I mean by that? That this circuit provides zero resistance.
No, like, sir,
Zero
what
res
is short circuit, sir?
Yeah, short circuit means that the circuit is so no resistance is provided by this portion. So the current will pass directly through it. No resistance would be there. So current would be maximum. That is the idea. Okay. If it would have been some device, so there would be some resistance to this current. But if this has been short circuited, so there would be no resistance. That is the idea of short circuit, right? So the current
Yes,
will
sir.
flow. The current will flow through the short circuit, and in open circuit, the connection has been tampered, right? So because it is providing infinite resistance, right? If something is providing infinite resistance, so can the current pass through it? No, right? So that is
Yes, sir.
that you guys will understand in film. So did you guys? Yeah. So have you guys studied about this semiconductor device? Did you guys studied about this p-n junction diode?
P-type and type, sir.
Yeah, p-type and n-type semiconductor. And then did you guys study this junction, p-n junction diode?
Sir.
Yeah, your voice is echoing. So in p-n junction diode, we have these filters, L-pass filters, pi filters. So in that case, yeah, these properties are used, right? So from this AC supply, right? So in the generator, you get this kind of supply, right? From the generator. And then from some filter, so from rectifier, so you have this full wave rectifier, half wave rectifier. So from half wave rectifier, you
So like
get
it converts alternating current to DC supply.
yeah. So that is the idea of the L pass filters, right? So first we use this full wave rectifier to convert it into this, and then we use some filters to convert them into this kind of. These these are the property that we use in these filters. Okay, did you guys note down this part? Noted. Yeah, I wanted to at least complete this RC circuit and LR circuit. The important ones. Yes, is it? Did you guys note it down? Noted.
Certain sir.
Yes, sorry. What about you?
Yes, sir.
Okay, so now let us read some question based on this, and then we will do this RC again. But all the concept, yeah, so whatever we have done, so these questions can yes, this is the question. So you have a very high frequency. So for the case of very high frequency, which one is open circuit, which one is closed circuit? Just remember. Just remember that we have this relation. We have XC, which is 1
Exchange will
over.
be open.
Yo, yeah, think about it. Think about it. Which one would be open circuit? Open circuit means that the current will not pass through it. It will provide the highest resistance, right? Let's say, let's say you have two streets, right? You are at this, and you have two streets. So there are many blockades in this path, and
XL is open.
XL is open. Now you are correct, right? Because omega L, so this omega is very high, so this would be very high. Let's say infinity. So high resistance, right? High resistance means that the current will not pass. This is open circuit, and this is larger, right? So we will have zero resistance. So if we have zero resistance, which means short circuit, right? So the overall diagram of this thing would be what? So this would be the overall diagram. So you have this resistance. This is now short circuit. So this is short circuited, and then you have this resistance, and this is open circuit, right? So this is the diagram, right? And what is the other diagram that you have? Then this one is also short circuited, right? And then this one is again short circuited, and this one is again short circuited, right? So then what is the diagram that right? Also two. And then this is connected to this supply, AC supply. So remember, this is the RMS value. Always remember this is the RMS value. So we have to calculate the effective impedance of the given circuit. So ultimately we have to calculate the resistance, right? So what would be that? So the effective diagram of this thing is this 1 ohm, and then this thing, and then this thing, right? So this is your diagram, right? And this is connected to this 220. So what is the effective resistance that you have? This is 2 ohm, this is 2 ohm. So this is 2 into 2 divided by 4. So that is 1 ohm again. So that
So
would be how
total
much?
two.
So this is your effective diagram. This is 1 ohm, and this is also 1, right? Connected to this AC supply. What would be this impedance, right? Impedance is how much? Z is V naught by R, right? And V naught is how much? So this is the
Sir, I
RMS.
not be root.
Yeah, your voice is echoing. Yes, what did you say?
Sir, IRMS is equal to I not be root.
Yeah,
Sorry, VRMS is equal to V
yeah.
naught.
VRMS is V naught by root, right? So then we can calculate this V naught. So that would be V naught by this is 220 by root, right? Oh, why did I write this V naught by R, right? So impedance is simply R square plus XC minus XL whole square, right? And we don't have any XC and XL circuit. So impedance would be always equal to this R equivalent. So R equivalent would be how much? That would be simply 2. So this would be the impedance, right? Is it clear, guys? Is it clear? So this would be 2.
Yes, sir.
Yeah, please note it down and because we don't have any other impedance is the effective resistance, right? And we only have this resistive circuit, so impedance would be just this.
Sir,
Yes, yes, Chavez, what are you saying?
like this is the impedance 2 ohm.
Yeah, so impedance is 2 ohm, right? Impedance is 2. Because this is open, right? And this 2 and 2, these are in parallel. So what would be the effective one? 2 into 2 divided by 2 plus 2. So 4 by, so that is 1 again. So 1, 1, they are connected in series, right? So impedance is effective resistance. So that would be the resistance, right? Because no other
Okay,
circuits are there. No other circuits are there. If we would have the other circuits like this one, right? Let's say this one and this one. Then we can use that this is R and R, so that would be 2R whole square plus this capacitive one, so XC whole square, right? But XC is very right. This is very what this is open circuit, so this is 0. So that would be only resistive part, right? So yeah, is it clear? What is it clear? Yes, guys, clear doubts? Said, which is equal to. Yes, clear everyone.
Yes.
Yes. Noted, guys. Tariq and Shavin,
Sir,
you are noting it down. Whenever you guys have completed. Yeah, whenever you guys have completed these. Yes, guys, noted. Yes, whenever you guys have put it down. Yes, Shaved and Tariq, noted, guys. Why are you guys saying?
Yes, 1 minute.
Go.
sir.
Then, yeah, Tariq, whenever you have.
The JEE exam, when is it?
Yeah, in the JEE exam, yes.
First attempt is on 22nd January.
22nd January. Okay, yeah. Okay, the first book will be complete. That
Yes, sir, done.
I guess first book will be completing by that, and we have to. Yeah, then from the uh, wave optics and ray optics, whatever you have learned from the CBSE portion, that would be enough. And atoms and nuclei, yeah, that one. And what about your CBSE exams? Please focus on that only, right? Because your exam will start on 15th February, right? So make a daily target
Yes.
And also,
and
it's 21st.
21st. Yeah, so
No, sir, it's like 22nd, right?
Yes,
22nd. Yeah, so focus on that because you have how many? Let's say 1 month and 20 days. Make a daily target, and you have physics, chemistry, math, and all the other subjects. So try to complete one chapter in 2 days. And all, let's say you have physics, you have, yes, so you have maths also. You have chemistry, and what is the fourth subject that you guys have?
Sir, I have biology.
Biology.
Yes, sir.
Bio, oh, that is very tough. And what about you, Tarif?
That's a computer science. Minus the
Computer.
last.
Okay, so computer science, right? So what you guys do is that you guys make a daily target of let's say half chapter, and half chapter, and let's say you give 1 hour and 1 hour and 1 hour. All these chapters, right? So aim make your goal that before 31st January you complete all these chapters, right? Yeah, you have to complete all these chapters before 31st Jan so that you can recap all these chapters in February. Yeah, this is very
Okay, sir.
crucial. Yeah, make a daily target, right? That is very important. So, try to set some
Sir,
goals. Yes. Yeah, your voice is very yeah, that is echoing too much. Yes, what did you
sir,
say?
like for to
Yeah,
solve.
yes. What did you say? Because your voice is echoing too much, and yeah, can you hear Tarif? Can you hear what Shavi?
Sir, yeah, can you hear me, sir?
Yeah, I can. Yes.
Sir, like for JEE numericals, like where you have to solve it, like from which guide, any.
Yeah, so I'm taking the reference from this Arihant JEE solve papers, right? So that would be enough. And yeah, you can take this HC Verma as well, and then PM Sharma would be very tough. Just focus on this Arihant, the previous question papers, and then this HC Verma and SL Arora. That would be also the three books. Those are more than right. Okay,
Done, sir.
so yeah, you guys have noted, but focus on this part, right? Now focus on CBSE part. And yeah, let us do one other question. We have enough time to complete that. Ideal what would be the okay, I guess the time is good. So I wanted to start this part. This part. Okay, I guess we'll do this next time. I will send you guys some question. You guys please try those because yeah, concept
Sir,
part. Yes, yes, yes,
like
Shavi.
in JEE LC oscillations,
Yeah, LC oscillation is also there, right? We have LC oscillation.
because in CBC it's not there.
Yeah, LC oscillation you have RC circuit, you have RL circuit, all these circuits you have. And in RC and RL you don't have this fluctuating current that you are supplying, but fluctuating voltage. This supply is not there. In RC and RL circuit, you have this kind of combinations. You have this DC supply, and then you have connected with this capacitance and this. So you have this charging condition, and then you have this discharging condition. So that we have to calculate, and this we will calculate from usual. Yeah. So you guys already know this linear integration, right? Or linear differential equation.
Yes, sir.
So yeah, this equation we will solve. So this is what? This is Q by C. This is IR, and this is equal to this V. Right. So how can we solve this thing? This I is dq by dt. Right. So dq by dt
Yes,
R,
sir.
and then this R. So then we will get dq by dt. This R we take in this divide by R, divide by R, divide by R. So we will get Q by RC, and then we would get V naught by R. So this is your linear equation, right? dy by dx plus your y, and let's say
Sir, 1 by
by
RC is the
1 by r says this b, right? So
yes, sir.
then this is b naught by r. So then you have to, yeah, well, in the next class, I wanted to complete this thing in the today's class, but we didn't get the time. So in the next class, we'll solve this RC and LR circuit, right? And finally, what you will get, so you'll get Q naught 1 minus T by R. So you will get the charging condition, right? So if you increase the time, then this is decreasing, so it will increase the time at maximum. So this is charging condition, and then you have discharging, which is Q max and E minus tau by R. So this is discharging condition. We will, the next class will solve this, right? So, okay, we'll stop at here, and yeah, I guess the next class we'll talk about that. Okay.
Thanks.
Allah Hafiz, Tarif and Chavez. Yeah, you guys be punctual, right? Chavez, after so many days, we